Alright, today we will be building this Christmas tree. You see it's made out of three parts on the circuit board, the base and the two trees. Looking at the schematic diagram, we can see that this tree uses a bunch of LEDs, light emitting diodes, and it uses 6 transistors. This is in a ring oscillator pattern, which will help with the LED flickering pattern. Of course, these LEDs are also special LEDs because they have their own flicker mechanism. They have 3 individual lights in them and a little integrated circuit inside them that causes them to blink. So, pretty interesting package here. Okay, so we got some screws. That's to hold the battery pack on. Some resistors. Let me get the LEDs into the bin here, all the loose parts. Some more resistors. Some LEDs stuck in here. All loose in the packaging. Okay, let me just dump this onto the table here because there's a lot of parts here. So let me sort these out. We got some more resistors. We have, of course, this transistors for the ring oscillator. Got a little power switch there. So let me separate these parts. Transistor, capacitor, transistor, let's put all the transistors over here. There should be at least 6 of them. 6 transistors. Yep, I have 6 transistors here. I have 1, 2, 3, 4, 5, 6 transistors. 1, 2, 3, 4 capacitors. Looks like 6 capacitors. 6 capacitors. Put those here. Push button and a bunch of LEDs. Just put all those in the bin there. I mean, they're not showing the values down on here, so I have to use schematic. So I know R1 is 10K, R3 is 10K, R5 is 10K, the R7 is 2.2K, R6. So basically all the odd resistors look like they're 10Ks. All the even resistors are 1Ks, except for this one 2.2K resistor, which is most likely this individual one here with a color pattern of, I think that is red. Let me use my trusty dusty calculator here. Mode resistors with 4 color patterns. So I'm going to say red. So that's 2.2K, and of course it's gold for an error tolerance of 5%. So that's what it says there. So this is the 2.2K resistor. So let me go ahead and just put that on R7. If I can find where R7 is. R7. R5, R3, R2, R1, R6, R7. R7 is right there. So I'm going to bend the leads, and I'm just going to stick R7 through those holes there. Now I did notice that the 10K resistors are labeled, and those are all the odd ones. So 10K, see now, this would be brown, so brown would be 1, black is 0, and orange is 3. So that would, according to my calculator, be the 10K ones. So mode, see now, R4, brown, black, red. No, sorry, orange would be the Reset that. Brown, black, orange is the 10K resistors. So this one right here, brown, black, red, would be the 1K resistors. Alright, to confirm that these are indeed the 10K resistors, because it is difficult to tell the difference between orange and red, I'm going to use my multimeter. I'm just going to hook up the multimeter to one of the resistors here, using these nice little probes, and this should say 10K. And it says 1K. So these are the 1K resistors. It's a good thing I confirmed. Which means that these are the orange ones. And these are the 10K resistors. Alright. Good thing I checked. Because as I said, it is sometimes difficult to tell the difference between red and orange on these resistors. So now let's install the 10K resistors. So basically all the odd number resistors are 10K. Now, I don't have a Christmas tree in my house. I'm not opposed to Christmas trees, it's just since I don't really have a family, I don't really see the point in having one, besides being something for the cat to play on. But, you know, we're not really supposed to be entertaining cats here with Christmas decorations. And there should be one more 10K resistor to install. Let's go ahead and solder these. Go ahead. Oh, Christmas tree, how beautiful and bright. Okay, I know, keep my day job. Soldering is a useful skill to learn, by the way, so it doesn't matter what occupation you are. If you know how to solder, you can do a lot of things. Do a lot of hobby-related projects, fix things. You know, you don't have to be an electrician or an engineer to solder. Plus, you know, building these little kits are a lot of fun, so. Earlier this week, I did a live Facebook video of me building my calculator. Unfortunately, part 2 didn't have any sound. Go figure. Kind of disappointing. Part 2 is just me assembling the case. Part 1, I built the calculator and troubleshooted it a little bit. But, oh well. Can't win them all, I suppose. And I just made a minor little error here. Got some solder in a neighboring solder hole, so I had to clean that out. And to do that, I use a little soldering braid. Get my snips. Get a fresh piece off. And just desolder that out of the hole there. we don't, with that solder there, it's going to be difficult to put an LED in that hole there. That's a problem. Oh well. Now we're just going to turn these leads off here and do the 1K resistors. This should be easy because there's only 1K resistors left on the circuit board. So when I make these videos, I record them using Open Broadcaster. I have a couple of webcams. The computer's only capable of doing 2 high HD webcams at one time. So I do plan to eventually build a new computer that has multiple PCIe slots, so that I can get more cameras operating, a higher definition, etc. But you know, I don't make any money off of these videos, so it's not exactly a high priority to do that. In fact, these videos technically cost me money because I had to buy the kits and tools and we have one more resistor. Where does it go? Right here. All right. There are not too many components to this kit. It does have a lot of LEDs, but that's no big deal. Try not to get solder in the next hole over. They're kind of close to each other. Here. Okay, that goes. Oh, that's a mistake. This resistor is going through one of the transistor holes. It didn't look right. That's what happens when you have things so close to each other sometimes. Like that doesn't make sense. Well, that's because it's wrong. So now that we got all the resistors installed, we can cut off all the leads. Just going to Okay, that looks good. The next component we're going to install are the capacitors. These capacitors are electrolytic capacitors, which means they do have a positive and negative end. As you can see, the capacitor has a white stripe and a shorter lead here. The white stripe will correspond to the white stripe on the circuit board, and it's also the negative side. So what the instructions want us to do is they want us to install and bend the capacitors down so that they're not sitting straight up, but like this. So I'm going to carefully bend it and then bend the leads to hold them in place so that the capacitors are facing downward. Shouldn't be too big of a deal. So the negative matches the negative side here. Negative is on the right side here, so we'll set that up. Bend the capacitor down and spread the leads out. Negative is on the left side here, so it's the opposite of the first resistor, or I mean capacitor. Capacitor, not resistor, George. Capacitors store a charge. But another thing about capacitors is they do not allow current to flow unless the capacitor is almost completely charged. And a capacitor never really gets completely charged. It just gets to almost completely charged. They're often used as filters to clean up signals. So negative's on the left side here. Just bend that back and bend the leads to hold in place. Go further out a little bit. There we go. Negative is on the inside. Yeah, if you plug the capacitor in backwards, the circuit's not going to work. At least not work properly. It won't work as intended, I should say that. These are 47 microfarad capacitors, in case you're curious. Okay, I have all the capacitors set up. Now we'll just have to get the leads arranged so I can solder. This is lead-based solder. I don't use that lead-free stuff. Lead-free requires higher temperatures, and it's just not as easy to work with as the lead stuff. I'm also using the fume extractor to extract some of these fumes. Doesn't get 100% of them, but it does a fairly good job. I think I bridged those two connections there. Probably did. Did I bridge those? Yep, that is a bridge. No biggie. What I do is just clean off the tip of the soldering iron, and then just move the soldering iron in between. It will basically suck up the solder. Check for any bridges. That's good. That's good. That's good. Awesome. So now we're done with the capacitors. Now that we're done soldering the capacitors, we can remove the leads. Let me check this underneath the magnifying glass just to verify that there are no issues. Ooh. So that one side's done. Yeah, I cleared out that hole. Good. Alright, next we have the transistors. All the transistors are the same. They're 9014 transistors. There's 6 of them. And transistors have 3 pins. They have a base, which is the middle pin, a collector, and an emitter. And when there's a small amount of current on the base, it allows current to flow through the collector out the emitter. The schematic diagram here shows which direction the transistor faces, because you can see the transistor has a flat end, so the flat end matches the flat end on the diagram. So I'm going to do is I'm going to bend these out a little bit, and then bend them in a little bit. So we've got one transistor here. Now typically the transistors, these are so close to each other on a circuit board, I often create bridges when I solder them. It's kind of hard not to do. Maybe I should try using a thinner solder. Maybe try that. Okay. So I've got one transistor down, 5 to go. So let's bend that down a little bit. Thankfully, all these transistors are the same, because if not, I'd look under the magnifying glass to see what they are, see what the writing says, because there's no way to read it. The naked eye is just. Transistors are important. They act as a switch or an amplifier. They're used in all kinds of circuits, and they're probably one of the most important inventions of the modern era. Without them, you want to be able to make computer memory, computer processors. You couldn't have logic, so programming would be impossible. Okay, we got the transistors ready to solder. Yeah, this is going to be fun, because it's hard to see what I'm doing. I'm going to do this under the magnifying glass here. That should help. And I'm also going to use the thinner solder to help reduce the chance of me adding too much solder. The next project video, which I'll be making next week, is a surface mount project. There will be Christmas tree decorations, little snowflake ornaments, blinking LEDs that are controlled by a really tiny microprocessor. So a little computer chip, the size of an ant, basically. And that I will be using the microscope. And that is just absolutely beautiful soldering, using the smaller solder apparently helped quite a bit. It's just absolutely perfect soldering. There are no bridges. Decent amount of solder on that. I'm just very happy with that. Okay, do the other side. Yeah, I got the thinner solder when I was doing surface mount stuff because you use the bigger solder, you bury the part in solder. Of course, also if you're using a soldering iron, you use a much smaller tip. Let me straighten out the solder. There we go. Beautiful. Now the soldering iron is at 400 degrees Celsius, which means you definitely don't want to touch the business end of this. It will immediately burn you without any hesitation. No, kind of like that stupid stock photograph showing the woman holding the soldering iron like a pencil. Not only that, she was soldering the wrong side of the board. So, anyways, the transistors are installed, and they are absolutely beautiful. I think. So now I'm just cutting off the leads. Let me just check under the magnifying again, see if there's any obvious problems. Don't see any. Cut off the leads off of this one. And if you don't hold on to the leads as you're chopping them off, they go flying. And you'll find them later on when you're walking around the room barefoot. You feel a sharp stabbing pain in your foot, and you know where they are. So, see, we got plenty done on this. All that's left is basically well, the base and the LEDs. Let's do the LEDs first. Now, LEDs means a light emitting diode. The diode only lets current flow through one way. There are two leads. The shorter lead is the negative. And oftentimes the LED will be flat on the negative side, which this isn't. I can hardly see the schematic diagram. So I think positive lead goes into the square hole. So, of course, the square hole is on the opposite side of the. Lovely. Okay, well, basically the LEDs go in like this, but we're supposed to again bend them so that the LED is on the surface of the. Okay, so we will continue to do that. So positive goes this way. Okay, need to bend the LED over and then bend leads back. So we're making a little sideways pattern here. These are going to stay in place. I think not. I think I just need to solder these as I do them. Solder these in place. Okay, let's get some more of these LEDs on. This is going to take a while. We got one side of the Christmas tree done. Just one more to go. we now have another side completed. Awesome. Alright, next we're going to install the power button. Which goes on right here. Stick some pins. Just go like that. Doesn't look too complicated. Really doesn't. Right? Just solder this one end on here. We'll solder this other end on here to hold it in place. Make sure it's nice and level. It is. And then we can go ahead and solder the other 4 leads. Check the magnification, make sure everything is alright. It looks good. And we also have the power USB power cable connector, 5 volts input. It isn't a particularly strong connector because it doesn't have the outside leads there, but oh well. So this will allow you to power by USB, 5 volts. It comes with the USB cable, by the way. Check the under magnification, make sure no shorting out. It looks good. And then we got the battery pack. So we'll go on this way. We want to run the black and the red wire through this one hole, so that's the negative wire goes through, and then the red wire is the positive wire, using standard electrical color codes, I suppose you'd call it. And then I just need to align this up to the screw holes. Using my magnetic screwdriver, I'll pick up one of these screws. Using my finger to hold the screw in place, I'm just going to tighten these nuts here. So I don't drop the nut. So we got the nut in place. Grab the other screw. Tighten the nut. And I just hold the nut in place and tighten the screws. Yeah. All right. So you have negative, positive, positive, negative. So it does indicate which side is which. Positive, positive, negative, negative, positive, positive. So negative, positive. Okay. That's pretty good. Alright, let me figure out a good angle for this, I suppose. Melt a ton of solder down. Oh yeah, this is working. I'm just melting that. Yeah, this is working really well. The solder is seeping through the little hole there and seeping to the other side. So yeah, this is working quite well. So what I'm doing is I'm got to get these wires out of the way so I don't melt them. Just do that. Anyway, so what I'm doing is I'm getting the solder, and there's a pad there. I'm just heating up the pad and putting the solder there, melting the tree onto the pad. And as you can see, it's pretty secure there. Okay, at the top of the tree, we're supposed to install another light, and there is a negative and there is a positive. It tells you which one's which. So this is going to be fun. So right there it says positive, right there it says negative. So we are just going to bridge like that. LED at the top of the that is pretty cool. Oh, Christmas tree, oh Christmas tree, how beautiful and bright. First of all, I hope I didn't have excess soldering on the soldering iron. Clean my tip here. That will allow me to. This is not exactly the most stable soldering surface. But then again, instead of soldering the LED in place, I end up soldering solder on the lead. Yeah, they don't got the best lighting either. Spin that back a little bit to help out with that. More stability here. There's a fruit fly flying around my nose. How annoying. One lead down. One to go. Okay, that's shopping day until Christmas. Did you get your shopping started? Better have. You don't want to forget me, you know. Alright, now we need to solder the wires onto here. So this red will go into here. But as you can see, it's much too long. So what I'm going to do is I'm going to chop off a piece, trim off the excess plastic insulation, turn that around and put it inside the positive hole. But first I should tin it. Let's tin it. Tinning's a lot of fun. You just get a soldering iron, and just put a little solder on it. Yeah, like that. And just bend it over and stick it into the positive hole. Come on. I know you want to go in there. Oh, wait. Problem is the tip of the wire is has a little bump on it, so we just need to chip off that little bump. Run it into like so. Yep, that's solder on. Do the same thing with the negative wire. Actually, I want to push this in a little bit. Just push this in a little bit so that the insulation is up to the. So I'm just going to melt the solder a little bit and just push, and that gives us a little better lead. And I'm just going to bend this back a little bit so it's not shorting out with the negative. There you go. So, chop off about here. Strip off the insulation. Tin it. That's what happens when you touch it before the solder thaws. Hardens is it gets a little tip, which means you can't feed it through the hole. So, but I want to feed it through the hole. So now I'm going to feed this through the hole carefully. Just going to push it through. Come on. I can barely see what I'm doing. And I don't want to accidentally break off the lead because I don't got much wire to play with after I chop that off. Okay, that's good. Now I can solder that into place. Okay. Okay, let's see if this works. I am going to plug, see what the positive goes in. Positive is right here, so I'm going to plug the negative on this lead, and I am going to plug the positive onto that lead. Because I don't have any double A's. Oh, Christmas tree, oh, Christmas tree, how beautiful and bright. We have a couple LEDs that are failing light. This one here, this one here, this one here, this one here. And that might be because I got them backwards. It's possible I got them backwards, but yeah, that's very pretty. I could probably correct those by reversing them.